Hey everybody, Corey and Victoria here. We are the Professors Du Bois, and in this video lecture we're going to talk about the stoichiometry of reactions involving gases.
All right, remember stoichiometry? We've been using this all semester long, right? So we've been using this with masses and with particles, and we've really been talking mostly with liquids or solids, and now we're going to extend that out to gases. And in order to do stoichiometry, and what is stoichiometry? It's calculations using the mole-mole ratio. So for reaction stoichiometry, we use the mole-mole ratios of the things that are in the reaction, and the number of moles is designated by the coefficient. So in order to use this mole-mole ratio, we're going to be able to calculate moles for gases, and we have two ways to do that. One is the ideal gas law, which is PV equals nRT, and you can solve for N, which is moles, or if you're at STP, you can use this conversion factor, which is 1 mole of gas occupies 22.4 liters. Okay, so what's that mean? STP is a set of conditions, standard conditions, so that we can speak about different reactions at STP, and we can compare results knowing that they were done at the same conditions. Standard temperature and pressure is what it stands for, and the temperature is 0 degrees Celsius and the pressure is 1 atmosphere. So at those conditions, any gas, doesn't matter what gas it is, will occupy 22.4 liters.
So we like to use this little mole island representation to help us visualize these problems. So we would have a balanced equation, and we would have information about one of the items in the balanced equation, and we'd have to get to the number of moles of that, and then use the balanced equation, the mole-mole ratios from the coefficients, to go to another compound or element in the reaction. So if we have a gas and we have a pressure, volume, and temperature, we can solve for N. We have R. We always have R. That's the constant. So given those, we can solve for N, get onto what we call mole island, have the number of moles, then use our balanced equation in the mole-mole ratios to convert to moles of something else. Then, if it were a gas, we could solve for the pressure, we could solve for the volume, we could solve for the temperature.
All right, the other way that we can get onto mole island or calculate moles is if we are at STP, we can use that 1 mole equals 22.4 liters. So we have to go from volume in liters, and we can convert that into moles. And of course, we can get off the mole island that way as well.
So here we have an example. We have a balanced chemical reaction up on top, and we have a 10-liter flask, and a lot of times when I'm doing these questions, I'll kind of pull the data out to the side. I recognize the unit, liters, that's a volume. Propanol, that's our C3H8O. Temperature's at 20 degrees C. We'll have to convert that to Kelvin, and we have a pressure in PSI. We'll have to convert that into atmospheres. So we want to know how many grams of carbon dioxide can be formed. That's the CO2. So we're given information about propanol, and we're going to have to find information about carbon dioxide. So the first thing to do is figure out how many moles of propanol do we have. So go ahead.
Okay, so here's our roadmap, so to speak. We have our conditions for a gas, and we have enough information that we can solve for moles. That gets us onto mole island, but that's with the propanol, and the propanol is the C3H8O, oxygen. So that gets us onto mole island, and then we can use our mole-mole ratio, which is our coefficients from our balanced equation. Make sure you balance your equation. And then that converts it into CO2. So that's what we were talking about. If you have information about one thing and you need information about another thing, you have to go to mole island. You have to convert it to moles first. So once we have moles of CO2, we can get off the island with anything, right? Anything that we know already. In this case, it's asking for mass. We know how to do this. We know that to convert from moles to grams, we use the molar mass.
So first we have to do our conversions, and that's really driven by that R, the ideal gas law constant. Units on that are liter atmosphere per mole Kelvin. So we're going to turn that PSI into atmospheres, and we have a conversion factor here. 1 atmosphere is equal to 14.696 PSI. So the PSI cancels, we're left with units of atmospheres, and converting Celsius to Kelvin just requires adding 273.15 to the value in Celsius.
All right, now we have enough information to use our ideal gas law, convert that into moles, and we're still just talking about the propanol here. So we had information about the tank of propanol, so that gives us our moles of propanol when we solve for N.
With the moles of propanol, we're going to take the coefficients from the balanced equation, and notice how we put the 6 moles of CO2 over the 2 moles of propanol, and that'll allow the moles propanol to cancel. So we've just converted to moles CO2, then using the molar mass, we can get the grams of CO2.
Just like you always have. Here's your practice. We're going to use the same reaction and ask you 2 different questions here. So pause the video and give them a try. All right, there's your answers. 3,768 liters. That's a lot, but we did start with 2.3 kg of propanol, so that probably makes sense.
So I think some places you could have went wrong on this is maybe not converting the kilograms correctly. So we would want to go to grams and then to
moles for molar mass.
Right,
yep.
Right. And what about the other one? That looks pretty straightforward, unless you forgot to convert to Kelvin, maybe with the 22.0. Those would be the biggest mistakes, I think.
Right. Thanks so much for joining us. Hopefully this helped clear up some stoichiometry mysteries, and come back anytime and join us for more chemistry. Bye-bye.